Okay, so it seems we are live now.
Just something funny.
And I'm gonna share my screen in a few seconds. Screen. Okay. All right. All right, guys. So this is our fourth meeting, I think, right? Third, fourth, I'm not sure. Meeting, fourth. Okay. And the plan today is to talk a little bit about data structures in Python. So the last meeting we started introducing a couple of syntax about Python, nothing really fancy. So I'm not sure also if you guys had the chance to go through these specific practice book. I pasted the link in the group Google Groups page. If you guys don't really remember or for some reason you didn't watch or wasn't here in the last meeting, this practice book was organized by this guy here, and then the Shitty Po2. So seems to be like a really good quick way of having an experience with Python. I like because it's all based on examples, so it's, to me, it's like the best possible way to explore something new that we haven't tried before. Okay, so but before we start going through the data stuff on Python, I just want to quickly show you guys what I'm currently working on. This is more like a way to, especially for people which hasn't done anything in Python yet, and or anything related to data science. As I mentioned before, I'm working on unstructured data, so I'm dealing with text, basically, analytics over text. So I'm using a lot of scikit-learn's functions and libraries. And I'm mostly using this environment here, the Python notebook, the Jupyter, sorry, notebook, to develop my work, my experiments. So in this part here, you see a lot of imports, so libraries that I'm importing. Most are from scikit-learn's. And we can actually take a look at the import syntax in Python. It's kind of interesting because in Python we call the libraries, we actually call them modules. So like there's people which call them libraries also, but the most frequent term for that is modules. So a module is essentially a directory that you have on your Python path, and then there's an organization of files inside this folder, this directory, and this makes basically that's what makes it a module. So a module can be, I mean, as simple as that. I mean, you don't have to do anything really fancy. That is one file that is required. I'm not gonna actually go through the details about this now, but there's just so you guys know, there's only one file that is required that you put on the folder, so Python can recognize that folder as being a source for code. So that's pretty much it. It's pretty simple. And back to the syntax. Here we see kind of two ways of doing the imports. Like in this first line here, you just use import and then the name of the module. Some modules are like built-in, so not really built-in, but it's more like they ship with the Python default package already, so you don't have to install it. But a few modules you have to actually install them. And one of the ways that you can install is by using like Conda, or there's also a more a little bit older kind of library package manager called pip. It's even more popular than using Conda. So there's people which prefers one or the other. So far, I don't really know. I mean, enough to actually compare these two. And
you just basically put it on the path, and then you say import this and this folder, basically.
Yeah, for these, like CSV is a module, so there will be a corresponding folder in the libraries path for Python. So everything goes inside. Everything for CSV goes inside this folder. That's just that. And if you want to develop your own module, you're just gonna create a folder in a specific path, or in the current path. You can also like the path that the script is running. You can use it. Yeah, you can just create a subfolder from this path. It also works. So this way here in the first line, we are just using the module name. In the second way, we are actually using two terms. So the first one is the module name, and the second one is the actual function or structure that we're gonna use. So here usually is either a class or a function that will come here. You can also like use, instead of using this way, you can use if you have like a couple of subfolders, you can use the parent folder here and then a subfolder here, so it also works. So like there's actually a lot of different ways of doing this, and based on the way that you do that, also that will change the way that you're gonna access the functions and the library itself. Because if you use it like that, then you will have to reference the whole path of the function. So you have to use module name dot function in order to access the function. If you do it like that, like in the second line, then here the second one here is a class. So you don't have to use the whole name in this case, because you already specified a particular class or function, so, or a variable. You can use anything here actually, and so this way I can directly use the ordered dict, which is the ordered dictionary. So I mean, sometimes it's easier doing one way, sometimes it's easier doing another way. But there's no really a rule for that. So if I scroll down a little bit, this is a variable definition. Here I'm creating a set. We're gonna talk about sets in a minute. From another structure. So this is actually a class with a initializer, which is the equivalent of a constructor for the most of the languages. Python can be object oriented, but the terminology and the way the classes works are not really like exactly like Java or more traditional kind of object oriented programming languages. So I'm not really going to go through the specifics here. So just so you guys can check, like this is a function, another function. And also a possibility that we have, like as I did in this specific file, is to kind of wrap everything that you have, like functions, in a separate file. and then you kind of clean up your high-level interface of coding. So you have, it's like that idea of having multiple layers of coding, like the MVC framework or similar frameworks that like use separate layers to code. So, or separate files. Usually that corresponds at least to separate files for different things. So that's the kind of reasoning that we use. And that's a good thing to hide stuff. Like here, I have that's all that I have in my script. So it's a really short script. But if you take a look at experiments, that's what I'm gonna show. This is like a huge file that have a lot of things defined. So I can kind of hide, you know, all this more raw coding from my main interface of coding. That also helps a lot and makes things a little bit more organized. That's a good practice to do in any language, actually, this kind of thing. All right, so we can close these now, and let's go back to.
So is it like an interface or something?
It's not really an interface as a Java interface. It's more like a way of programming. So like Java, you know, in Java we create a lot of Java files. So usually a Java file corresponds to a class. So here in Python it's not the same, but you can create files to organize your code or your project. So you don't have to create a project. I mean, in Python, as it is a really simple, the objective is that you are able to start doing anything right away. So you can have a function, a program with no functions defined, like the simplest possible script. You can have functions defined. You can have classes defined. You can have things defined in separate files or in separate in a file structure like subfolders and everything. So it can grow and get more complex as you need, but it can also be as simple as needed if you have a really short kind of project.
Can you go back to the previous interface? But if you import something as tags, notice.
Oh, close that. Let me open it again.
Yes, the experiments is actually a folder on the disk.
It's a file. Because I can also use that. In this specific case, we don't call it module because it's just a file. So because it's just a file, it's an import of a file.
It's a .py file.
It's a .py, yeah. I can show the.
Where should we put this if you want to run this script and import?
The easiest way is to leave in the same path as the current running code. Like I'm running on a Python notebook, so you have to know where the notebook is. In my case, it is here. So, like the notebook I just opened is this one, LDA4, and the .py is this one. So it just needs to be in the same in the same folder. That's enough. If it is not, then you have to use the Python path. So and that's environment dependent. So depending on your environment, you have to figure that. It is usually like a subfolder of the main Python installation.
What is the IPYNB?
This is the IPython notebook. Or Jupyter notebook.
Just this file is just generated from the tool you use.
Yeah, yeah. The notebook
is still like a script.
Yeah, it's very similar to our regular .py file. The only difference is that it carries some layout definitions, so you can actually have this more interesting way of dealing with the data. I have to have a Jupyter notebook server running in my machine in order to use this interface. So, and as we've seen in the previous meetings, you only have to install the Anaconda distribution to have that. So as long as you have the Anaconda, then you have the Jupyter environment. So you are able to run these files, and you are able to develop on your browser. There. Okay, so let's start with the data stuff, right? So in Python, there's not a lot of built-in data types in Python. There's the primitive types are like int, float, string, but other than that, you also have like built-in variable types for a function or class, so that's also possible. Lambda definitions for lambda functions or lambda expressions. So it's not really different from most of the languages, but other than these primitives, I can also have very useful kind of data structures, which are the lists, the tuples, the sets, and there's also the dictionaries, which are really useful also. But there's one thing, there's the strings, sorry, and there's this thing that really makes people which code with Python life easier, which is called list comprehension. So this is something that the first time I had an experience with this was like when I think a month, 2 months ago. So I was starting to learn Python. So I came with this kind of syntax, kind of strange syntax. It's a little bit close to how R deal with arrays, but not really that. I mean, not the same thing. So to be short, it's a really neat way of creating lists, and you can create lists and like do an iteration and do a lot of checks, everything in a single line. After you have to get used to that, it's really, really powerful, and you do a lot of things in a really short kind of syntax. So let's start with the basics. The first thing that we're going to talk about are the lists. And a list is, as you can see here, pretty much a list of elements. So if I have like 4 numbers, and I want to store those 4 numbers in some kind of structure, so I'll just create a list. The identifier for a list in Python is the squared bracket. So if you use a square bracket with elements inside them, then you are pretty much creating a list. One thing that is being shown here, very interesting, is that you don't have to have every single element in the same kind. So you can actually mix like strings, ints, floats, whatever. And it's by itself, that's something that's really powerful. Also, a list is, in a couple of ways, is very similar to an array, because you can access an element by the index. So you can use an index to like consult a value or update a value or do some kind of calculation. One very interesting thing also that you can consider is that one of the elements of a list can actually be a list. So that's something really interesting, and that makes it like really, really flexible to store whatever you think you might need. There's a built-in function called range. We're gonna really use this function a lot if you are going to code in Python. So a range is pretty much a short way of creating a list, and it can just take one argument, as in this first example. So if you only use one argument, you're pretty much creating a list of 4 elements starting in 0. So it's like a sequence that auto increments from 0. You can also define the first element that are going to be like the first one, and then until the very last one. But that's one important thing here to observe. Here, the last element is non-inclusive. So what that means is that the last element that you specify here, it will not be created. So in this case, if you do a range from 3 to 6, you are actually creating the elements 3, 4, and 5, and not the 6th one. Okay. In a lot of different places, Python deals with ranges in this specific way. Like if you wanna specify, we're gonna have in a few moments. We're gonna have an example of a slice. So when you specify a slice of like a list or a structure, then you actually have to use the same kind of notation. So the last element is not non-inclusive, and that's also something that's kind of not so friendly, not very intuitive, because the first element is inclusive, but the last one is not. So it's kind of weird at the beginning, but you get used to it. You can also specify this way. So this is the jump that you do from, like, if you specify a third argument, you're actually incrementing by that amount that is specified. So here I'm incrementing from 2 to 10 in steps of 3. So 2 plus 3, 5 plus 3 again, 8. All right. So that's what you got. And you don't have to specify like this doesn't have to match like the mod of this operation. Like 2 mod 3 doesn't have to be 0. So in this specific case, it's okay to use whatever number as the last one. Another very used built-in function is the len function. So len pretty much stands for length, and it returns the size of a specific variable. You can use not only with lists, but with a lot of different kinds of variables. However, not every variable will be able to be calculated using len. That's because there are specific variables which, like I'm gonna use an example that I probably used before. There's a variable type called the CSR in NumPy. So this is a kind of a sparse matrix representation. So in this case, if I use len, that will not work. But the CSR has a built-in object called shape, so you can consult this object to actually consult the size of the specific matrix that you have. So just don't take that as like a rule for every single kind of variable, but most of the time you can use len to calculate the size. So here's in this example, I have like 4 elements. I could just say len of A, and then it will return the size, which is 4. I can also use operators, the plus and the multiply, the asterisk operator on lists. So what that means, take a look at this example. What that means is actually kind of intuitive. So if you have a list A and a list B, and you sum those 2 lists, what it will do is it will concatenate these 2 lists into one single list that has the sum of the elements of A plus the sum of the elements of B. Not the sum, sorry, the number of elements from A and the number of elements from B. And if I want to do a multiplication, I'm not going to actually use the multiplication word because that's not really what's happening, but that's the asterisk. So in this case, I don't even know how to call this operation, but in this case, it is actually, yeah, repeating the elements of the list. So here it says lists can also be indexed by the individual entries. So you can actually, as it is on most matrix representations, matrix language syntax, you use the square bracket after the variable name and an index number. So that allows you to consult a specific value from the list. If you specify a wrong index, it will throw you an error, of course. And if you use negative numbers, it will actually go from the end towards the beginning of the list. So it's also a neat way of, like, if you want to get the last element, you just use -1.
So it like wraps around, like.
Yeah, kind of, yeah. And as I was telling you guys before, you can slice a list. So slicing a list is pretty much what you can get from the idea of slicing. You get a view, an extract from the list. You can specify like an interval. So in this example, I have 4 elements, which goes from 0 to 3. And if I say x 0 to 2, here what I'm gonna get is the elements 0 and the element 1. So remember that in this case, the last specified index is non-inclusive. So that means you are not getting the last element that you specified. That's really important. In the second example here, I'm specifying from 1 to 4. So 1 is the second element because the index starts at 0, right? So I'm getting the second, the third, and that's it. I'm sorry. Is that it? Oh, yeah. This one, yeah. That's because 4 is like after the last element. Like the last element here is 3. So if I say 4, I'm getting actually until 3. And that's still valid. Okay, got it? The last element here is the index 3. So if I specify 1 to 4, I'm actually getting 1, 2, and 3, and not 4. And that's what it's returning here. I can also use negative indexes on slices. So that pretty much means that the same way if you use a single index, it counts from the end of the list. So here I'm just saying from 0 until the last one.
So it's basically the second argument is just a count. So let's say starting.
No, it's not a count. It's like it's the actual index. It'll match the count if the first element is 0.
Oh, I see.
But the first element can be like 5. So
I see.
from 5 to 6, it's just 5.
Okay.
I think we can actually pause here and open a notebook to start doing that. New. So let's say X is a list with the elements 1, 2, 3, and 4. And I wanna get the last element. How do I do? What? -1, yeah. If I want to get the second element and the third element, how do I do it?
1, 2, 3.
Right. What else? Close this one too. Oh, this is also an interesting one. 0 to -1. 3. Oh, actually, this one is not getting the last one. This is one before the last one, right? Yeah. Yeah. See, this is very tricky. Sometimes you don't really, you think you got it, but you didn't. I don't know why I keep scrolling. It's not the right. Okay, what else did we get? Oh, this is also interesting and useful. If you, let me zoom. If you say like, column 2, what is that supposed to mean?
Start from 0.
Start from 0, and it takes 0 and 1. But
Right.
It doesn't include them.
Right. Actually, it does include the 1. It just does include the 2.
It doesn't include the 2.
Yeah, right. Is that what I say? Sorry. Is that what it said?
Yeah.
I'm sorry.
It's fine.
So here it's the same as using 0 to 2 or 0, 2. Like, let's say I want the first 3 elements. How would I do it this way? Yeah.
0 to 4. You can exclude the 0 and just put 3.
Right.
And there will be 0, 1, 2.
Correct. Stop doing that. You know, I'm gonna put this in a different. Yeah, that'll be easier. Okay. Let's do this way. It's better. Oh, we could actually use the splitted screen from. Yeah. Oh, nice. The new OS X has this full screen split kind of. All right. So here we can create a variable using the range built-in function. But in case of the Python notebook, you also have to use the print to show the stuff, right? Okay, this is interesting. Let's begin with the iteration. There's an operator called n. So let's see what we can do in n. Let's say you have the x list as we had before, and you want to check for a specific element for this element if there's a corresponding one in the list or not. So if you say like redefine x and let's say 2 in x, it returns true, which means 2 is an element of x. But what about 9? False. So there's no elements. There's no element 9 in x. But what if I come here and do like x dot append 9, and then I do the same thing? 9 in next. Oh, it says true. And you just saw a way of adding a new element to a list.
Adding at the end.
In the end, yeah. A list it keeps the order of the elements that you added. So and you can add multiple elements with the same value. Like if I add a second element with 9, I have 2 elements with 9. That's an important thing because there's a data structure that we're gonna see in a moment called set, which it only holds unique values. So for a set, if I do that, if I add an element, a 9 element, and I add it again, so it keeps the same way. So let's see. One of the really common way of using a for in Python is with lists. So if you want, let's say you want to do a for with a variable is gonna vary from 0 to a specific number, let's say 5, whatever. So you can actually do like this: for I in range 5, print I. So what I'm gonna do here is I'm gonna print the variable which varies from 0 to 5, which is specified by the range. The range function actually returns a list. So I can do this way, but I can also do like this. Oh, sorry, 0 to, yeah. That'll be the same thing. You can use a last to do the iteration of a for, and that's really, really common. So this is already a good way of like a lot of times Python kind of makes you write less, so be more short on what you're writing. So this is really interesting, and if you take a look, the most popular, like most frequent data types, they will have some kind of iterator to make you go through it, through the values that it holds. There's also a built-in function called zip. So for the zip function, what it does is it takes 2 lists and it returns a list of pairs. So it gets like the first element from the first list, the first element from the second list, it binds them together and creates a tuple and returns this pair as the first element of a list. So here's an example, like if I do, yeah, here's the example. You can take a look. The first list is a list of strings. So you have the A, the B, and the C. The second list is a list of numbers. So if you do zip, it will get the first element from the first list and the first element from the second list, and it will bind them together in a single tuple. And a tuple is just a sequence of elements. It's similar to a list, but more primitive, more simpler. So not every.
Can be extended to more than 2 lists, right?
The zip, you mean?
Yeah.
I think so. We can try. I never tried before, but we can try it right now. I'm only gonna do 2 elements per list to make it quicker. should print. Why is it is not printing? Yeah, it worked. This is also one interesting thing that we didn't see before. In these four, I'm actually getting 3 variables from this element. So this element is a zip element. So it's it's not a simple list, but it's pretty similar to a list. However, each entity will return a sequence, a number of individual entries. So the first entry will actually return 3 elements to me. So that's what it is doing, and that's why I can use 3 variables here, and I can call them whatever I want. It will know that's the first, the second, and the third element. I just come here and then say, oh, let's do ABC, and then ABC. It'll still work. This is actually the example that I just showed you guys. There's also a built-in function called sum, which takes a list of elements and just sums it, which is like summing a vector. It's the same thing. A lot of times you can just see a list. I mean, if you're doing some operations, if you take a list, it's almost the same as a vector, a mathematical vector. And what about if I use strings instead of like numbers? So it will still work, but in this case, it will just concatenate the strings. That's also something kind of interesting. If you wanna, let's say, oh, I wanna do this, I wanna concatenate, but I would like to have like a space between every 2 elements. So how could I do that? I haven't showed you guys yet. Oh, what have I done? What have I done? Here. Yeah, there's this way I can come here and say drawing. You'll get concatenated divided by the spaces. I can also, let's say, I want to do a comma. And you got. So these tricks are really, really powerful. Like, look how many like lines have I spent here. Sometimes you spend like 3, 4, 5, 6 lines to do this, right? Factorial. You don't have to go through every single example here, but min and max, these are really, really, really useful also. Like you have a list and you want to know which is the minimum element. Let's say here we have oh yeah, here X has elements 1, 2, 4. So the min of X would be, find X somewhere. Let me actually redo that. X equals 0, 1, 2. Why not use range? 4, and then minimum of X, return 0, because X is from 0 to 3, right? So what about if I do max? Do you guys think it will return? 3, right? Have we showed how to define a function the last time? Yeah? Okay. Yeah, just use def and then the name and arguments. Okay, there's also a sort method that you can use. It will just sort the elements. We can do a quick example, like A equals 3735186 Then I want to sort. Oh, sorry, sort. Here he goes. Oh, there's actually a sort also. Let me see if that works. It does. It does not. I don't know why. We can stick to sorted. And we have tuples. So the same as a list, a tuple is a sequence, like a number of individual values, but a tuple cannot be like changed. So in case of a list, as we've seen before, you can use append to add a new element. You can also delete an element from a list. In case of a tuple, it's like a constant, so you're not gonna be able to do that. And the tuple is that a list uses parentheses. So you can create like that. You can still index an element, same as in a list. You can also use the slicing, so exactly the same way you do with lists. And this is also one thing that's worth mentioning. If you want to create a single element tuple, if you try to do that in Python, like the first way I could think of doing that would be like A equals parentheses 3. That would not actually create a tuple. If you want to create a tuple, you're gonna have to put a comma right after the value that you are creating. So that will create a single element tuple. And that's important because sometimes you need an iterator, and a tuple is an iterator, but a single element is not. So if you want to go like do a for one element, or a case that can return one element, a single element, so you have to be careful with this kind of thing, because a tuple of one element is not the same as a single element. You also have sets. So sets are also similar to lists, but the difference is that in a set, you always have unique elements. You cannot have two elements with the same value. So I can quickly show you what I mean by that, by creating like a list. 3, 1, 2, and then printing list, and then creating a set. Actually, set from this list and printing this set. Let's take a look at it. The first result, I have 1, 2, 3, 1, 2. So I have 2 numbers 1s and 2 numbers 2s. The second element, I only have unique elements. And also the notation here for the output, the curly brackets. So this is actually the curly brackets are used for both the dictionaries and the sets. And you're gonna understand why when we talk about the dictionaries. So we also have strings. Oh, for sets, I forgot to tell you guys. For sets, I can still add elements and remove, but there's a special kind of set called frozen set, which is like a constant set. So you are not able to add or remove elements. It's just a constant, and it's called frozen set. And everything that you do with a set, you could do with a frozen set, but the adding and removing elements. So strings are you can actually see a string as a list of characters. It's a way of seeing it, and you can actually use the index syntax and the slicing to select a specific character from the string or a sequence, an interval, same way we did before. So it's exactly the same kind of syntax for slicing a list or other data types. There's also this operator here again, in, which is really useful. Like if you want to know if a substring is part of a larger string, you can use this way. So it's a quick way of doing a really simple regular expression. There is the join mention, a method that built-in function that I mentioned before. There's also the strip, which does the opposite. Let's say you have a string with words separated by spaces or like comma, and you want to strip every single one. So it will return a actually, I'm sorry, that's not, no, that's to strips just to remove. Yeah, right? Yeah, to strips just to remove. I was talking about the split. It's a different thing.
Strip, just remove the empty.
Right. No, I mean, you remove whatever you want. You can, if you specify strip space, then it will remove every space.
The string can take like argument.
Yeah, like to abracadabra. Let's strip. Let's remove the 8s. So
and the left strip and the right strip still work. Like
oh, it's,
It didn't remove all things.
yeah, it didn't remove every single way. It seems to just remove the first and the last, right?
That's the effective.
Yeah.
Because the strip only like remove from the head and the tail.
Oh,
Yeah,
right. So you got it. All right.
Also have two versions, like L strip and R strip, left and. But I don't know whether the L strip and the R strip will still like do this way.
Like that?
You can see change A to B. Maybe.
The argument.
Argument A.
E.
B. B.
Oh, B.
Yeah, and use left strip, L strip.
Yeah, it just gets the first one. Do you have any use for that?
Yeah, usually you remove like the tracing spaces and ending spaces, or like for example, you have like a new line. If you want to remove that as well.
If you want to remove like everything that appears, you can use like replace.
Yeah, there's a replace. Yeah. There's also a split that we use a lot. Like I was.
In Java, they have trim function.
Yeah. Right. So let me just show the split, and then we can move forward. If I want to split by space, it will return a list of elements.
Oh wow!
That's very useful. And you can actually use that to read a CSV file pretty easily. Okay. Well, I'm not gonna talk about working with files today, so I'll just jump over that. We can talk a little bit about file operations in the next meeting. And I just want to show the list comprehension syntax, and then we can stop for today. So please take a look at these examples here and see if you guys can understand what's going on. Have any of you guys used list comprehensions before? Have you? Okay.
I think it's very similar to like apply function in R.
Yeah.
Yeah. That is very useful.
It is.
Oh, this is kind of cool. You take it in square brackets and it returns a.
Isn't it that like a for each loop?
It's a little bit more powerful than a for, because it does the iteration, but it also can check for a condition. It's like a for plus an if.
It was a parameter by itself, and then it shows a list of all the multiplications of every single lane, of every single element in the list. Yeah.
So let's take a look here. A is like a simple list, a range of 10, so it goes from 0 to 9. All right, and I can actually do that.
Do a similar thing with Java collectibles. Pretty cool. It's very small.
So if I say a list comprehension this way, let's just paste it here. Here, what I'm doing is I'm getting a value for every single element that exists on A. So you can see A, I can call A is actually not iterable. This iterable will return one element at a time. So this element would be like, call it element. And on this element, you can do any kind of operation, like you can take, let's say, the squared root, the power of 2 of this element. Whoa, what have I done?
To name it element where you have X.
Oh, right.
No, not there. Where you have X.
All right, yeah. Also, I have to in the same names actually. I can do the other way also. That was work. Yeah. You can actually do whatever you want with X. Like, let's say X is like something that you want to use on a query, on a, I don't know, on a web service or something like that, and get the return and use it as the value for this element of the list.
You can call a function with X as its parameter.
Yeah. Let me show that. I mean, I'll create a really lame function like add ink. I can just use like that.
You probably can like nest those.
You can.
Statements. Can you?
Yeah, I've tried it before.
But in R, you can.
No, in Python you can also. That's what I said.
Really?
Yeah, you can have a list comprehension of a list comprehension.
So like a function defined in a list comprehension.
Define. What do you mean by define?
Like like in R, you can just say call this inc function and then define it immediately in the expression. You don't have to define outside because
Oh,
you
yeah,
only
yeah.
want to use once.
That's how we were doing before, like this. Right? Okay. Sometimes you just prefer to call a function on the value.
Yeah, like you can just instead of yeah, you can just call inc x and then right after that you define the function, and that function will be like disposed right after this expression, like in R. But I don't know whether you can do that.
Walk me how would that be? Like inc.
Yeah, I don't think we can do this here.
Oh, you mean we can't do that in Python? Is that it?
Yeah, but we can do that in R.
Oh, okay.
Like inner function or inner method.
Can you do it?
It's like an abstract class.
No,
It's like inline function.
anonymous.
Okay. Like JavaScript inline function.
You just define the function within this square bracket.
Yeah, yes, like that.
Yeah. In Python, I'm not sure if there's like an equivalent of that. There are lambda expressions that that might solve the same kind of. Okay, and we can, I mean, just to show you guys that this can get really powerful. Like I can have imagine that actually before I'll do the more complex one. Let me show just one thing. If x not in 0 and 1, that's also something that's valid. So a little bit of spicy in the list comprehension. So now you have a conditional, and you can actually filter specific values. You can also use a function here if you want, like something really complex that you don't want to put everything in a line. So just create a function, and a function should return true or false, and then that's enough. I can also do something like this. Do you guys see what's going on? So here I have, I mean, I obviously have a list comprehension inside a list comprehension, but the fancy thing is I'm using variables in a function from both the list comprehension. Like this function here is getting an x and an y. The x is coming from the inner values of a, the inner list comprehension, and the y is coming from the outer list. So it's coming from B. There's one more, a little bit complicated way that I can do. Like, let's go back a little bit. In this case, it's doing something different, but it's a little bit, it's also kind of powerful because I'm nesting fours. So I can have as much fours as I need. Like, let's say you need 4 nested fours. So it will iterate through every single element of the first one. And then after every single element of the second one, second iteration, second 4, and then every single element of the third. So this actually has a multiplication effect. Like, I'll have X times Y iterations, right? It's like going through a matrix. If you have like a 2D matrix, imagine that you have 2 dimensions. So the first dimension is X, the second is Y. You want to go through every single element. You can use 2 fors, right? 2 loops. So this is what it is doing. It is going through every single line and every single column. Was I clear about this one? Yeah. Yeah. Okay, so that's pretty much what I was thinking about showing you guys today. The list comprehension thing, to me, is really, really awesome. So I really was looking forward to show it to you guys. I don't know if you guys think it as, I mean, it is as nice as I think, but I think it's really nice to have a really short way of expressing that much. So imagine having to do that with force. So imagine having to do that. Let's actually do that. What would that be? For X in A, right? Then for Y in B. And that's Python. So Python is already very short. But that's not really what's being done here, because here I'm creating a list. So I'd have to initiate a list, and I'll have to append this list with the results. It would be the equivalent. So 4 Python lines into 1. And 4 Python lines is already like equivalent to 8 lines in Java, right?
I mean, you have in as well, just column that you do like 4, and then you do declare your variable column.
You can use for each, right? On Java.
It's like for each, but now also with lambda expression, you can do it also very easily. You would do something like you did here, list equals, and then you can do like instead of int, it's just column. You have to declare like here. You don't have to declare x and y. It's like implicit.
All right, guys. Do you guys have any more questions? We can.
So like when I was installing Python, right? There's like a version 2, right? And version 3, right?
Yeah.
And there's like huge difference between them.
Yeah, it's like I sent some links to you guys about this subject, but I mean, there's like a suggestion that you should try to use the latest version now. If you are starting using Python, you should start with 3, And then eventually we will need to use a little bit of 2, depending on the thing that we're gonna use, the library that you're gonna need.
Or can you mix them together?
There's something called 2 to 3 and 3 to 2. These are 2 modules that you can use to they parse the code and kind of converts one code to another. But it's a semi-automatic way because not 100% of the code is convertible. So sometimes you have to manually go through the code and update or
it's not really
downgrade.
backwards compatible.
No, it's not. I mean, it's very similar, but it was not one of the objectives. Like 3 should not be able. It's not a demand that it be able to run every single Python 2 code. So
when you do work with data packages, is most software written in version 2?
Most most modules are now like compatible with 3.
Oh, I see.
So I haven't tried using those modules on 2, but I'm very successful using everything on 3. So to me, using 3 was enough. And if you have a need to use 2, you can just install a virtual environment with 2 and use it. It's very simple in Conda. So if you have like a way of running both versions of Python on your machine, that'll be the way to go, because that'll make it possible to you to run whatever code you need. But if you have to choose, like you're gonna start doing something, so I'll start with 3, and then from there you can make up your mind.
Unfortunately, all my teammates at work, they use Perl.
Yeah.
Pretty old.
Yeah, there's people which say Python is a modern version of Perl, because Perl also was created as a scripting language to automate like Unix-related tasks, and a lot of those automations are now actually done in Python.
Yeah, I mean, a lot of like if you look at Linux, a lot of stuff like in script are actually Python.
Yeah.
It's like what I kind of like about Python is that you can actually do object-oriented.
Yeah. It's kind of a simplified way.
They have like a hack, but it's not the real thing. They don't
Yeah.
really support object-oriented.
Yeah, there's a lot of things that you can do in Python. Like if you want to do object orientation, an object is really close to a function. So it's that they share this understanding of the data type with Java. So sorry, with JavaScript, because JavaScript, an object is pretty much kind of anything. It's so generic that you can store a function inside an object. You can store another object inside of an object. You can store an array of something. I mean, so in Python it's kind of the same thing. You can have a class which holds a function, which holds another class, which holds another function, and then goes on. Let me stop the recording. All right, guys. Hope you guys enjoyed. See you guys in the next one.